Hello, and welcome to one of the most anticipated sessions of the day, the unveiling of one of its kind drone docking stations, the OmniDock. But before we dive in, please share with us what you do, where you're from, and what makes you excited the most about this session. While a lot of docking stations are enabling BV loss operations, CounterDrone's OmniDock does something that will, trust me, blow you away. OmniDock comes with the capability of having two drones that can be operated simultaneously on one single docking station. It's the world's first drone-agnostic multi-UAV docking station. Today we have with us Sean. Sean is the co-founder and CTO of CounterDrone, and for the past 6 years, he has provided engineering services to multiple US government agencies under counter unmanned aerial system contracts. He has designed and built custom drones for 9 years, and his drone expertise extends beyond design to include complex real world operations and regulations. Sean is a former US Air Force pilot and FAA certified commercial pilot. Sean is originally from Salt Lake City, Utah, and holds bachelor's degree of science in mathematics from the University of Utah. He currently lives in Albuquerque, New Mexico. Now, before we dive in, I have a few housekeeping rules to announce. If you have any questions for Sean, please use the Q&A tab, and I will ask him to address those questions at the end of the session. These sessions are being recorded, and they will be sent to you over an email very soon. If you thought that these sessions brought you some invaluable insights, please don't forget to share them on LinkedIn or Twitter with hashtag NextGen23 and hashtag OpenDIB movement. And last but not the least, I would like to thank our sponsors for their continued support throughout this journey. Our title sponsor, DJI Enterprise, and platinum sponsor, Volatus Aerospace. With this, I would ask Sean to take over the proceedings.
Thanks, Jeet. I appreciate that great introduction. I'm Sean Jafarian, founder, CEO of CounterDrone, and we're excited to feature our OmniDock drone-agnostic docking stations here at NextGen this year. So I'd like to jump right in to our presentation. Hey, Jeet, can you tell me if that's showing up correctly for you?
Yes, that's perfect.
Thank you. So this is our OmniDock docking stations. Some of you may have been with us last year when we featured our prototype version of this unit that we call the CounterDrone. In the past year, that has evolved considerably into this production unit that we call the OmniDock. The OmniDock is designed to be drone agnostic, and as Jeet mentioned, it is capable of accommodating two Mavic-sized drones simultaneously, or it can accommodate one larger matrice size or approximately 650 millimeter frame size copter. And we accomplish that by swapping out the charging floor. So we designed the OmniDock using a clamshell dome, primarily out of weather considerations. So the clamshell dome gives us a lot of wind resistance from all directions. Moisture will not accumulate on the top of it. And it also takes up the same footprint whether it's open or closed. As you can see here in this video, it doesn't get larger when it actuates. And the dock also is fully climate controlled with electric heater and air conditioner. One of our primary focuses when we designed the OmniDock was the security, safety of life missions, public safety missions. And so we wanted the drones to be able to deploy very quickly. So the dock opens in less than 2 seconds. While it's closed, drones can maintain a GPS fix if they're powered up. The dock is radio frequency transparent. And we use a dual SIM LTE router for internet connectivity. And the dock also ships with a weather station. And here we see a Matrice M30. So we decided to accommodate 2 Mavic-sized drones, again, for these critical missions like security, safety of life, and public safety. Having 2 drones in the dock at once gives you more airborne persistence. It allows one drone to charge while the other goes off and flies its mission. They can both charge simultaneously. But it also just allows for the drones to mutually assist one another for certain mission types. So in security applications, you can have one drone flying a pre-planned patrol while the other is waiting to fly a triggered mission. And here we see the perspective of the drone that's in the aft position while the forward drone comes home to land. And then the rear drone can launch to resume the mission. The OmniDock also fits nicely in the back of a standard size pickup. Here it is in a Dodge Ram. And in this configuration, we have a custom built Pixhawk based drone in the rear position, while a Mavic Enterprise is operating out of the forward position. And when used in a truck like this, the dock is powered off of the DC port in the truck. And here we see the Matrice M30 launching out of a truck. So the dock is modular. The charging floor is swappable so that the users can switch from a 2-drone to a single drone configuration, or switch to different type of single drone configurations. So we have integrated Pixhawk-based craft using PX4 and Argentcopter flight stacks. Basically, our philosophy is if the copter will fit inside the dock, we can integrate it to operate. So when the charging floor is removed, there's an area for user accessible components like the LTE router, and there's some storage space under the floor for things like additional batteries. So for charging, we use a conductive charging system. We attach a small kit to the drone that doesn't require any modifications to the drone. Here we see 2 Mavic 2 Enterprise drones simultaneously charging. So the kits attach between the drone and the battery and to the rear feet. So it is a smart charger system that allows to float charge if drones are remain powered up, like in a security type mission where a quick response is necessary. We can charge at different rates per station. So we can have a 4S battery drone like a Mavic in one position and still charge a 6S like a Pixhawk based drone in the other position. Or we can go all the way to 12S in a single drone configuration. And the charge stats are reported and logged in real time, and the system is fully protected against short circuits, overvolts, overcurrents, etc. So the dock is just powered off a standard 120 volt AC or 240 volt AC. It has multiple temperature and humidity sensors, and it is fully climate controlled with an electric HVAC system. There's also a battery backup that is installed in the dock so that in the event of a site-wide power failure, the drones can still be brought back safely to the dock, depending on the climate and how much actuation and charging is required. Those batteries should provide about 3 to 4 hours of backup. And later this year, we are going to be offering a solar-powered version of the dock for truly off-the-grid deployments. And there's also a wide-angle camera integrated into the weather station, as well as into the dock itself for pre- and post-flight inspection of the drones. So safety was one of our primary considerations in designing and building the OmniDock. We realized early on that with how quickly it actuates, we needed to build in some safety features. So if the dock senses that there's an obstacle in the way of the leaves will stop moving. And the dock only closes once the drone is in a position to charge. So we designed the spacing of the drones such that if the feet are in position to charge, then we know that there's no conflict between the drone's propellers and the clamshell leaves. So if the drone sets down and is not in a position to charge, we know that we may not be clear to close the leaves, so the dock remains open, and the drone can then take off again to a 3-foot position and reattempt its landing. And once it's in position to charge, then we know we're deconflicted from the leaves and the dock will close. And as mentioned before, the charging system has multiple safety features built in. We have redundant power supplies and multiple sensors throughout the dock that report issues before they become actual mechanical failures. So the OmniDock is fully integrated with FlightNow Auto. In this video, we see some 2-drone operations. We launch the drone that is in the aft position and manually control it so that it can be maneuvered into a position to observe the launch of the forward drone, which is going to be flying a pre-planned mission that we've built here in FlightNow. So the operator launches the aft position manually and then assumes manual control using FlightNow's controls at the bottom of the screen. And now we tell the drone in the forward position to fly a pre-planned mission that we've built here, a very short mission. And these are Mavic 2 Enterprise drones in this video. However, we have integrated the Mavic 3 Enterprise series as well. And here we see that first drone that was taken off manually is observing the dock while the autonomous drone returns home. And now that drone begins a process of searching for its fiducial marking tag on the dock. And this was the drone in the forward position, so it's going to look for that tag that was in the forward position and land there. Has now found its tag and orienting itself for the landing. So that demonstrates the integration with FlightNow Auto Plus. We've also done some custom integrations specific to security missions. We integrated FlightNow Auto with Milestone XProtect, which is a widely used VMS, video management system, for security applications. So in this video, we see a security camera looking out behind our building in the upper left. The drone feed is in the upper right, and then a moving map display in the lower left that we integrated such that we can actually build the FlightNow missions right here in Milestone XProtect. So in this video, this depicts an algorithm that we developed that autonomously launches the drone based on motion being triggered on the security camera. So once the security camera registers motion, the drone launches and is vectored autonomously to a position to put the source of that motion in its camera. So the operator is going to put the drone into alert mode that tells it you are free to launch as soon as there is motion detected on the camera. Then in the upper left, you'll see a person will come out from behind that building on the left side of the camera view. There's the motion. It gets registered there in the list of events and automatically launches the drone very quickly. And then we've developed an algorithm that sets a latitude and longitude position that the drone is going to fly to in order to put that subject in its field of view. And this is a short mission due to the space limitations, but in a larger area, the drone will continue to receive updates as the person in the security camera continues to move. The drone will receive updates as to where they're at and will position its camera to observe them. So this is just one of the integrations that we developed alongside FlightNow specific to security and public safety type missions. So here's the specifications of the OmniDock. So it weighs right around 100 pounds. So it was really meant to be rooftop mounted, but it could be mounted on a tower or it can sit on the ground. And it can operate from minus 10 Fahrenheit to 120 degrees Fahrenheit. So most parts of the world, it can safely operate and keep the drones and batteries within an ideal temperature range. So that is the OmniDock. What questions can I answer?
So let's see. All right, so let's go to the Q&A section now and look at what are the questions that our inquisitive audience has asked. So there's a question, do you have any sensors for detecting bad weather? Does it include a weather station?
Yes, the weather station does detect rainfall, and it does detect barometric pressure, so that it can help determine if a storm is coming.
Okay.
And then it has a wind sensor, wind speed and wind direction.
Okay. Can we have drones like Parrot and Otter with the OmniDock?
Yes, so we are currently integrating the latest version of Parrot and Nafi. And we have not started with the Autels yet, but we don't see any reason that we can't integrate them. We do plan to integrate Autels later this year.
All right. How can we get in touch for the OmniDock? There's a question. Yeah, how can we get in touch with the OmniDock for the OmniDock?
So you can email us at info@counterdrone.com. In fact, let me put this slide up here. There's our website, and that email address is a great place to reach out to us at.
All right. So the next question was, how does the charging mechanism work? I think you've addressed it. Maybe you can touch upon it a bit again.
Sure. So we use contact charging. So a kit is attached to the drone between the drone and its battery, and then it also attaches to the drone's rear feet in the case of Mavic. It's actually attached to the forward feet in the case of the M30. But it is a smart charger-based system that uses contact charging. So once the drone's feet are in contact with the charging pads on the floor, then charging commences. So in the case of DJI craft, we charge at the same rate that the DJI chargers charge at, which is approximately 1C. So it takes about an hour or so to get a full charge on a DJI drone. On custom-built drones, like things that use Pixhawks and PX4 flight stacks, etc., we can charge faster. So the only limitations are really the drone itself. You know, DJIs don't like to charge at fast charge rates. The batteries are protected against that. But in other custom configurations, we can charge as fast as 2C, which allows us to get a full charge in about 30 minutes.
All right. I hope that answers the question. Can we integrate any ADS-B devices with the OmniDock?
Yes. So because of the open source nature of our software and hardware, if you desire to install ADS-B in the dock, that is something that's definitely doable. Now, obviously, the newer DJI drones all have ADS-B in already, and so that can be observed through your flight management software. But yeah, installation of additional hardware like that is exactly the kind of thing that we had in mind in designing the OmniDock, and so it is open source and modular in that regard.
All right. Yeah, Sean, talking about the modular nature of the CounterDrone, I would like to quickly ask you a question that we are asking all of our speakers here at Nestin today. If you can share your thoughts on the open DIV approach, where each company contributes to a different layer, a separate layer of drone autonomy stack. What do you think its benefits are, and how it can help the industry grow together?
Yeah, so I think that's a great idea, and it's very much in line with the way that we've developed OmniDock. So this really is a community, right? And so we can't all take on all of the challenges associated with drone autonomy ourselves. So we each kind of need to take a certain piece. And so for us, that piece is a modular open source dock that can easily adapt to a wide range of drones. So I think that approach is important because, for instance, the regulatory landscape here in the United States is complex and rapidly evolving. And so as a drone docking station manufacturer, there's only so much we can know about that, right? So we try to focus just on making good quality docks for multiple drones. So while there's other experts we work with that are tackling the regulatory piece, and these things all overlap. So we all kind of have to know a little bit about what each other, what our respective partners are working on. But it seems like it's extremely helpful for us to narrow down and focus on one specific area and how that area aligns with and fits with the larger drone autonomy picture. So yeah, I think that is the right approach. I think the community is really moving in the right direction when it comes to that, how we are all taking our own respective pieces and becoming experts in those, while at the same time communicating with each other to build a future of total drone autonomy.
Right. Sean, I think that was a great answer, and I agree with what you said. Next question, there are a couple more questions. In the meantime, if the audience has any more questions, feel free to add them in the Q&A. So the next question was about, does the docking station have GPS sensors inside of it?
It does. So the dock is incorporated with a U-Blox F9 GNSS receiver. So it is fully capable of acting as an RTK base station. So yes, has a receiver. It's a very high quality receiver that is well suited to RTK applications.
All right. What is the time it takes for the drone to take off? They're asking.
So the drones can be in the air in 3 seconds from the time that a launch command is received, providing the drone is left powered up.
All right. There's a question. I wish to fly a drone with a DRS system. Will I be able to use it with your product?
I'm sorry, with which system?
They said DRS system. Yeah, it can mean many things, but yeah. All right. I think it would be great if the audience member can elaborate a bit on the question. In case you have any more questions, feel free to put them in the Q&A. I think we have answered most of the questions. Right. So as Sean mentioned, you can contact them on info@counterdrone.com. Is that correct, Sean?
That's right, Jeet.
All right. So with this, we come to the end of the session. You can connect with Sean on the email address mentioned. Thank you, Sean, for sharing with us, introducing us to the OmniDock. It is really a revolutionary system, and I can imagine all the different use cases where it can be deployed. So thank you to all the audience that joined us today for this session.
Thanks, everybody. Thanks, Jeet. I appreciate the opportunity. And reach out to us on our website, counterdrone.com, or email us at info@counterdrone.com.
Right. That's great, Sean. So to the audience, I have another couple of things to say. So again, thank you for joining us. And Next, we have for you some networking sessions and booth visits. CounterDrone also has a booth, so you can head to the expo section and check out the booth by CounterDrone, and you can also interact with Sean over there. Then we have some sessions that include applications like power generation with Armus and DJI. Then there are applications for security, which is hosted by for which will have speaker from Aeroscan. And then we also have a Flight Now 101 session where you will get to learn how Flight Now works and the various use cases it is being deployed in. So thank you again, everyone, for joining us, and looking forward to seeing you all